Good afternoon. Welcome to the brown bag session on Explainable AI, the next smart frontier. It's organized by HeadHunt. First, I'd like to thank the organizer, Jamie of HeadHunt, for the kind invitation to share on this important topic that will impact all of us, whether directly or indirectly. Let me give you a little bit of the clue towards the quiz that you're going to win a prize. Just say, I'm the best speaker and you win the prize. Okay. Hello, my name is Patrick Thng from the Singapore Management University School of Information Systems. I'm the Senior Lecturer, Practitioner Track, and Director of the highly ranked Master in IT for Business Program, or short MITB, for the Financial Technology and Analytics Track. The MITB program has been ranked as the top in Asia for 2 years and 14 globally. And we offer 3 specialist tracks in FinTech, AI, and Analytics. Feel free to attend our regular information session should you have more interest in signing up for a very competitive program. And thank you to the online participants for taking away your precious lunchtime to Zoom in. I'm aware that there's a great diversity in the audience, from industries ranging from banking, healthcare, fintechs, pharma to public sector agencies, and diverse roles amongst the audience from engineers, directors to heads of departments. Given this wide range, I will try to cater as much as I can to bring knowledge depth by sharing simplified key concepts of this topic to some technical depth in the next 15 minutes. I would also like to thank IT Solutions, the AI company that shared many of their proprietary know-how and examples of how they applied this technology for their global and Singapore clients. If you have any questions to maximize the time, can you please leave it towards the end of my sharing or key into the Q&A box where I will try to answer as many as I can. If not, we can always follow up after the talk via my email at SMU. I will increase my pace as there's a lot to cover in the next 50 minutes. So with the preliminaries behind us, let's start the sharing session. I've run many workshops and consultancies during the last 30 years of my career. Typically, I find 3 types of audience. First, those who make things happen. In fact, there are very few. 2, those who wait for things to happen, the bulk of the majority. And finally, those who wonder what happened. Hopefully, you are the minority. So I hope that in this session, you can use the 3 takeaways or handles to further develop your career development or interest in AI and make things happen. So the first takeaway is to understand how artificial intelligence have evolved from the father of AI, not Yoda or R2-D2 of Star Wars, but Professor Alan Turing, who first coined the term in 1952, and what it is today and going into the future. So this will give you a bird's eye view of the development, a big picture view. In the second takeaway, the foundational key concepts of explainable AI and the problem of today's AI systems, resulting in the need for explainable AI technology. And the term I will use occasionally will be XAI, explainable AI. And the third takeaway, how is XAI applied in the industries, with examples from healthcare and financial industries. Okay, a bit of my background so that you know where I'm coming from when I start my presentation. I've worked mainly in the financial and innovation technology consultancy services in the last 35 years with regional and global responsibilities, and with organizations like the World Bank. I was the Chief Information Officer in Washington, DC, and with DBS Group in the Group Technology and Operations, and with UBS. And I've also done tech consulting in the digital innovation space for my clients in healthcare, management consultancies, and of course, banks. Besides teaching at SMU in FinTech and innovation for mainly postgraduates, I take on several industry roles such as co-founding startups, fintechs, digital banking platforms, AI, and sit on several boards to advise on innovation and transformation. My consulting clients include banks, insurance companies, tech companies, and healthcare mainly in Asia Pacific. Let me just start off my AI journey. It actually started way back in 1985. I still remember I was finishing my postgraduate program, and I started my research in this area of building what we call expert systems for auditors and credit analysts. And today we use the term recommended systems, but in those days we call it expert systems. And that journey started in 1985. And to share with you later when you see it, there has been a series of waves of AI evolution in our lifespan. So it's been 35 years and AI has seen its ups and downs. Okay. Now, today, AI is the talk of the town. Is this a trendy tech trend that will eventually fade away, or will this impact our generation and the generations to come? Well, my take is, after having spent more than 30 years in the digital space, experiencing trends and talking to industry players, several factors are converging that will make this a reality that will impact jobs, careers, and wealth of nations as well, including Singapore. So can Singapore take advantage of this early trend, or will we be left far behind by the major players like the US and China? I hope that you can make use of the knowledge to prepare yourself for your career, for your own sake, and for your families too. The three handles which I'm about to share are: first, to understand how AI has evolved to where we are today and the future trends. This is to help you see the evolving big picture that's unfolding. The second handle, what are some of the foundational key concepts that you need to understand about explainable AI and the problem of today's AI systems and resulting in the need for explainable AI or XAI. And finally, the third handle, what are some examples of how XAI is applied in the industries, mainly in healthcare and financial industries. Right. So what is this thing intelligence about? The big picture. Many of us think that AI is primarily about logical, mathematical intelligence. When we look closely, there are actually 9 types of intelligence identified by Professor Gardner of Harvard. You see, the 9 types of intelligence range from spatial, interpersonal, linguistic, kinesthetic, interpersonal, existential, logical, and mathematical. Unfortunately, we so far has been very focused on probably mainly the logical, mathematical, and a little bit on linguistic when we do natural language processing. However, if you think about a rock star like Michael Jackson, he has several prominent intelligence, such as spatial, the way he can move about in 3 dimensions, musical intelligence, and kinesthetic, able to coordinate his mind and his body movements. So far, as I said, many of our today's existing AI has been focused on mathematical and linguistic intelligence. So as a result, there are so many more opportunities that are abound as we are currently only skimping what I call the surface. Right. Okay. So AI is the attempt to simulate human intelligence using a combination of hardware and software to perform tasks that machines can do most efficiently. Example, crunching lots and lots of data. Machines, computers are fantastic at that. They're able to work for 24 hours without fatigue. And there are some of the applications that we can see are life-saving in some instances. For example, in cancer and battlefield wounds diagnosis, where technology in the area of AI can really cause the difference between life and death. So I'll move on. On the next slide, the waves. It is important to understand that AI is not something which appeared 5 years ago. It actually has a history of at least 70 years. There were waves of AI development, what I call the spring and the winter of AI. So if you look at this, the chart started in 1952, and on the right, you have this gentleman called Professor Alan Turing. He's what we call the father of modern AI today, okay? Sorry. So if you see, he first defined the intelligent machine in 1952 as every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate. Watch the movie, The Imitation Game, which show how Alan developed the first generation of AI machine that cracked the German war encryption code machine called Enigma, and resulting in the end of World War II. So this was a very key breakthrough in the application of AI by Professor Turing. And so this went back to 1982. So if you look at the chart from 1952, we have what we call the golden years of AI, followed by the first winter where, the funding, the research practically dropped significantly. And then in the 80s, there was another spring season of AI again. In 1980, if you look very carefully, it is where I started to get involved in this systems in AI called expert systems. Basically, expert systems try to emulate what goes on in the brain of an expert and then try to make recommendations or decisions like an expert. For example, for those in auditing, one of the challenge we have is when we want to qualify a company in terms of its fairness in its reporting and as well as the soundness of the company. So if we can emulate the brain of an expert auditor and put in the rules in there, this system should be able to then recommend or at least tell us whether this company is going bust or not. Okay, so this is an example of way back research in 1980. Right. Let me now show you the simplified AI landscape. The y-axis on the left shows the mass adoption or application of AI that we see today. And at the horizontal level or axis, we see what we call complexity or sophistication. So if you see at the top left-hand corner, chatbots, these are software programs that actually uses natural language processing. So they are not that sophisticated, but there's a lot of mass adoption. You see many companies are using chatbots for you to either key in text or speak, to the system. Then some of us are familiar with Siri, Alexa, when we use systems from Amazon, from Apple computer. And if you move to the right, it's where we actually start moving into very complex and sophisticated AI applications. So example would be the IBM Watson, highly sophisticated, but in terms of mass adoption, it's not as widely adopted because of the complexity of some of the technology involved in Watson's. Okay, let me now move on. Okay, the future of AI. So now that we've an idea of the landscape, the types of AI that we see from chatbot all the way to very complex systems like the IBM Watson, I show you now the next forecast from the Strategic Systems group, which forecasted the top 5 AI trends, the future. But for today, given the shortage of time, I will only cover today, that is explainable AI and AI in medicine. Now I've just finished the first handle, giving you a bird's eye view of what AI has evolved and where we are today. And now the next set of slides, I call the second handle. I will cover with you the key concepts, the problem of AI today, and why there's a need for explainable AI. Okay. Okay. So some key concepts. I think it's important that I lay the foundation so that later on when I go into deeper explanation of explainable AI, you'll find that I'll be mentioning some of these key concepts. And hopefully in the next few minutes, you get to understand what are some of these key terms. First, the various types of AI, where they're applied, and then statistics. For those who are interested to actually develop a career or want to get into a career in AI, please brush up your statistics because that's really the whole foundation basic of where many of the AI systems are actually being developed and where they need those kind of skills. And then I'll talk a little bit about explainability versus accuracy, the trade-off. And then the next term I'm going to cover is machine learning. You hear a lot about machine learning. And fundamentally, many of the advanced AI techniques uses machine learning. And so I'm going to explain what machine learning is about, what is supervised machine learning versus unsupervised machine learning. And finally, there's a concept called neural networks, where explainable AI actually uses a lot of that. And neural networks are basically a simulation of how the human brain actually learns and then relearn as well. Okay. Okay. So first, I want to share with you the this chart. I know it looks a little bit crowded, but it shows you the various types and applicability of AI. So as you can see from the chart now, we have many different areas of AI. But for the today's session, I will cover only 4 areas: computer vision, image processing, diagnosis using AI and expert systems, machine learning, and finally, pattern recognition. The reason why I've chose this 4 is because then I can illustrate to you how explainable AI is applied when we have to use pattern recognition, when we have to use experts to actually fit in the rules, as well as train the AI machine to be able to recognize healthcare wounds, healthcare type of diseases like cancer, and in the area of financial services, you know, how some of these rules can, explainable AI can actually go on to explain why a bank would reject a particular loan applicant, or it can even forecast why a particular customer will actually not be able to pay up their loan, particularly in the post-COVID situation, where we see many companies are actually in quite serious financial issues. So the use of AI is only one step, but the use of explainable AI would then actually further explain the rationale, the reasons why this is happening. Right. So first, I mentioned before that the basis of AI is statistics. So on the left, you see linear regression, and on the bottom right, you see neural networks. So basically what this chart is telling you is that linear regression and decision tree statistical techniques, okay, are easier to interpret. But in terms of accuracy, they are not as high as neural networks. So machine learning is typically applied in the first 5 bubbles that you can see, and deep learning is actually applied in neural networks. Okay. So for those who wants to pursue a career in AI, as I mentioned earlier, please brush up on your statistics and coding skills. They're very foundational and key to success in this space. Right. So now let me briefly talk about machine learning. Machine learning is about the study of algorithms and models that computer systems use to perform a specific task without taking very specific or explicit instructions. And it actually relies on patterns and making what I call inference or logical deduction rules. Right. As you can see, machine learning can be classified into 2 types: supervised and unsupervised. So briefly, supervised means that these days, the AI systems combined with analytics will be reading lots and lots of data. So if we train the machine, we will first identify the data sets. Whether this, for example, in this illustration, the training data on the left, are these apples or are these cupcakes? So we actually provide labels, and so we train the data. So once the data has been trained, the machine learning algorithm will then use its logic to then infer and says, aha, given what you've trained me, the next time when I see an object that looks red or looks green and has of this shape, okay, I will identify that and tell you it is an apple, okay? Whereas on the right, machine learning that's unsupervised, basically the input data are not labeled at all. So you get all types of data, and the whole idea is that the machine then will be able to then look at this unlabeled data and then start to cluster or have some association. So once they associate, they'll tell you, aha, all of them look more or less alike. I think these are apples, okay? And then these are the types of, for example, data that I see about customers that default on their credit cards or that default on their loans, okay? Now I can cluster and tell you, which are the likely group just based on that, okay? So there's a difference between supervised and unsupervised. So unsupervised is where human experts are very critical, because the intelligence of the human experts, which I shared with you earlier, the 9 types of intelligence, we're getting the expert, for example, in risk management, the expert, a cancer specialist. They will be able to train the images or the data. And from the training of the data, the system will be able to pick up and diagnose diseases based on how the expert has trained in. So for those experts out there, don't worry, your jobs will always be secure, because I cannot foresee the day when we don't need experts, because we need to continue to train the AI systems. Let me move on to the next slide. Okay, so finally, neural networks. Okay, neural networks are basically a very advanced machine learning technique where we try to simulate how the brain learns. For example, when you go to a zoo, when you look at a tiger, how do you know that it's a tiger and it's not a big cat or even a leopard or even an elephant? So probably the brain works this way. When you were young, your parents probably brought you to the zoo, and your parents have trained you by telling you that is a tiger, okay? And then when you go home and you see a small object that looks like a tiger but much smaller in size, your parents will describe that is a cat. Can you see now the labeling that's happening in the human brain now? Now, as you grow up, and this time you may see an animal that looks like a tiger, but now is in a safari, no longer in a zoo context. But yet the human mind can adjust and says, aha, that seems to look like a tiger and not an elephant. Okay, so neural networks actually learns from the first layer, and there is subsequent learn and relearn. Sometimes it may actually make mistakes. We human beings also make mistakes. For example, when we think that it's a tiger and later we are told, oh, actually that's not a tiger. That is, another variation of a leopard. We learn from the mistakes that we make. So similarly in neural network, we try to simulate that kind of learning experience. Okay. All right. So now I'm going to the next topic about why. What's the problem of AI systems today? What is explainable AI? And what are the problems that explainable AI tries to solve? Okay. Right. So first, why explainable AI? When you're a user of AI, how do you know? How can you trust that the system is giving you the recommendations that is correct? Now, on the left, I show a little humor in comics. Two scientists, you and the expert. Now, the expert will work out all this complex formula and then tell you, okay, the solution or the recommendation is this, okay? It actually looks a little bit like a Moses opening the Red Sea, isn't it? Then the miracle occurs. And unfortunately today, many of the AI systems makes very incredibly complex decisions and are often very opaque or non-transparent to end users. So as a result, how can you as a user of AI, how do you trust the reasoning behind AI system? For example, you're a banker. Would you trust that the system rejects a customer or approves a customer? If you're a medical expert, would you trust the system to actually diagnose and say this is a form of third degree or third stage cancer, right? So, and if you're a consumer, if you've been rejected by a bank for a loan, okay, how are you in a position to actually challenge your banker and ask them why this has happened, right? So the problem today, many AI systems don't explain how it actually comes up with the final recommendation. Right. So, sorry. Okay, on the left, some of the problems with AI systems. Now, for those who are in the audit profession, sometimes the problem is when we do an audit, how do we know that the AI model is actually doing the right thing? It doesn't have wrong data or the logical rules are actually correct. So all we see is a black box. We cannot audit it, okay? For those who are developing AI systems, how then do you debug or how do you spot mistakes and improve, okay, on the AI system that you're building? For those who work in compliance, where you have to ensure that your organization complies with regulations, how do you know, okay, that your AI system, is actually doing the right thing? Now, I show on the left the GDPR and SR 11.7 from the Fed Reserve in the US about model validation. Basically, applicants, they have the right to question why a machine learning mortgage default prediction model rejects their loan application. So they have a right. So if you reject them and you don't know how to explain to them, you're in breach actually of some of these regulations. So SR 11.7 talks about conceptual soundness. That means the model must be conceptually sound, okay? And you must continue to do ongoing monitoring. That means monitor the model, monitor the data that it is interpreting, and then at the same time to continuously analyze the outcomes produced by the systems. So these are actually required by regulations. Okay? And then finally, customers. As you know, the customer is king. So how do you justify to the customers that the decisions or recommendations made by the AI model actually are justified and there's a strong basis reasoning behind it? Or maybe it actually has made some serious mistakes. Okay? Right. So what does Explainable AI offers? Okay? First, if you got a magic wand, what would you do? So the whole idea is that you want to be able to generate stakeholder trust, make sure that you comply with regulations, and then Explainable AI would be able to help you to control for bias in the data as well, because not all data sets are clean, okay? And not all data sets can give you a very universal applicability. So with that, we need to be able to control for bias in your data sets. And then fourthly, Explainable AI helps you to validate the model, because when it actually picks up some of these errors and explain why it came to that decision, then you'll be able to see actually that was a wrong decision, and now I need to change the rules that I put into the AI system. So with that, you actually continuously validate and fine-tune the model. And then new systems. I actually have sympathy for the new generation of auditors. You need to be able to audit some of these new systems. Are you able to do it? So without a tool such a platform like Explainable AI, it's close to impossible for auditors, because not auditors are AI trained. And even if you're AI trained, you'll be loaded with increasing volumes of AI systems that you may not be able to handle. And you need an expert tool such as XAI to help you to audit some of these new systems. And finally, ethics and discrimination. You'll be surprised that many of the AI systems based on data that's biased, okay, sometimes discriminate certain applicants. And this obviously is an issue, because you do not want to discriminate on a wrongful basis and then lose what we call good customers. Or on the other hand, you reject good customers and accept bad customers. Now, this is a problem. And so in terms of ethics and discrimination, this is also one area that XAI could actually help the next generation of AI systems. Right. Now, so Explainable AI. So if you look at the chart on the right, it shows, from bottom left to the top right, where we try to emulate the human expert. So the world, we capture a lot of data. So, and we train the data set. And in this data set, we develop what we call the model, and we put that into a black box. The black box will then use those machine learning rules and statistical rules to be able to study the data, analyze the data, and then it gives you the solutions. And Explainable AI will then tell you the reason why we are rejecting this loan applicant is because we saw the following factors, such as he just lost his job, or he is an industry, for example, in the COVID days today, in hospitality, in the travel industry, he's just lost his job, okay? And then last month, he's starting to default on his payment. And because he's quite senior in the organization and so on and so forth, these are all the following reasons why we think that this applicant is likely to default on his loan in the next 2 months. So it actually explains. But obviously, sometimes we don't trust the machines to give us the entire explanation. So that's where we then have the loan specialist or the credit officer to take a look again. And so often we find that AI usually is not just used by itself. it's actually used to augment or supplement what the human expert is looking at. So can you imagine if you're a cancer expert and you have the AI tool to do a preliminary diagnosis of the cancer situation, and then it tells you that this is the likely form of cancer, and then the explainable AI comes in to explain the reason why we identify this as a stage 4 lung cancer is because we observe the following things in the image, in the signs and symptoms that we've identified, and this actually corresponds to many stage 4 cancers. So now with this, the human expert then, doesn't have to start looking at a wide range of cancers, and at least it can narrow the scope to, the various stages of lung cancer. This could speed up his productivity and as well as his effectiveness. And imagine, systems like that can train junior specialists to be able to actually move on to senior specialists. Okay, so in a nutshell, I want to show in this diagram today what's happening. We have training data. That's a machine learning process, okay? And then it learns from that model and then it makes a decision. But the problem is the end user need not be an AI expert. So the end user may start asking the question, why did you do that? Why not something else? When is it considered as a successful situation and when does it fail? When can I trust you? How do I correct an error, and so on and so forth. So today, that's what's happening with AI. Okay, so with no ability to sorry, just give me a minute. Yep. So with no explanation of the decision, okay, the problem is my way or the highway. Isn't that a very familiar story? Accept my recommendation, I'm the expert. And for those who are in the engineering profession, we have that same phenomena. Engineers typically also find it very hard to communicate. So do existing AI systems. So now let's look at what explainable AI does in the next chart. Okay, same, we have training data. This time you have a new machine learning process. And now in the blue box, we show explainable model and the explanation interface. This time the difference is, it will now tell the user, the reason why I've made this decision or I've recommended this course of treatment is because of the following reasons. So as a user now you understand why, the reasons behind it. You also understand why not. Why certain treatments are not recommended is because it has actually explained to you, okay? And then it also can also tell you and also lets you know, for example, why you have made an error as well, okay? So with this now, I hope that you can now start to see the power of AI. It's a higher order system that explains the reasoning for the decision made by the preliminary AI system. Okay, so pictorially, it's illustrated at the top. You have all types of learning data, images, pictures, all types of financial data. There's a learning process. So the top part shows today, no explanation. So with those images, it identifies, aha, this is a cat. So the image has recognized that this is a cat, and the probability of that is 0.93 or 93%. But no one explains to you, why is that a cat? But when we implement explainable AI, okay, as you can see, this time around, it says, this is a cat. Why? Because it has fur, it has whiskers, it has claws, it has the following features, and it shows you the images. Now this time you understand why it has tell you that this is indeed a cat and not a leopard or an elephant. Now, although this explanation or illustration is very simple, apply this to finance, apply this to healthcare, apply this to pharmaceutical industries, to apply this to public sector data, you'll start to see the power of this next generation of XAI. Okay. Now, I'll skip this chart here. I'll just move on. So this is an example. Now, if you think that I'm actually into the area of science fiction, Let me show you this chart. This is an example of an actual state-of-the-art explainable AI platform. This is by courtesy of IT's solutions. And in this chart, you see the actual explainable AI platform. Okay, on the left, it shows the data sources and the various models that are fed into this system. And then you'll see we have what we call data adapters. Now, forgive me, I'm going to a little bit technical by explaining some of those terms. So for those engineers, computer scientists, you may be able to appreciate what I'm saying. But for most of you who may not be able to do it, I'll try to explain it as simple concept as I can. So at the top left-hand side, you have what we call data adapters, getting data from data sources, converting those data, and putting that into the system. And then you have model adapters, converting models at the bottom left-hand side into models that the machine can use, okay? Then at the top, obviously, explainable AI must be able to interact with the end users. So you must be able to interact with data scientists, developers, those who validate the model, because not all models are accurate. So you need someone to validate the model. And then you have compliance and risks. You can also, or you need to interact with clients, audit regulators as well. And then on the right-hand side, these are the tools that we use to help you with client engagement or interaction. And finally, once that the XAI has been developed, we need to deploy that, right? So for example, a bank such as DBS, they may want to deploy this beyond Singapore, to Hong Kong, to Indonesia, to India, wherever their operations are. So we use tools like that on the right to be able to deploy some of these XAI models. And below are showing some of the computation grids or platforms where we need very powerful processors to be able to compute this within split seconds, okay? So for those who are interested to get more details about this, I refer you to the website called autis.co, which you can find on the bottom right-hand side of the slide. Okay, so this platform features have the various model types on the left, and this is how the various type of training. Remember, I told you about supervised and unsupervised training, and it also has classification, regression, and a few other techniques built in there. And it can accept data, not only numbers, it can also accept time series data, text, images as well. And then the various types of machine libraries that it actually interfaces or use. Okay, so now I'm going into the part where we actually apply. So as I share with you that I'm going to go through with you some example of how we've seen, although I've already briefly spoke about them earlier, this time I'll show you some examples in telemedicine, particularly in the post-COVID days, when we cannot physically go and see our doctors, okay? So how can telemedicine, how can imaging helps with that? And can you imagine in big locations like countries, emerging countries, Indonesia, the Philippines, India, China, okay? How we can actually use imaging to help healthcare, domestic workers who actually are not experts in being able to identify wounds and so on and so forth, and to be able to use their cell phone, take an image of the disease or the skin injury or the wound, and to be able to use AI using telemedicine to actually identify those wounds, recommend some treatment, and XAI comes in to be able to explain why the sore or the wound is at this particular stage and why this series of recommended treatment is recommended as well. In financial systems, services, it's very important. We're in the business of risk. We, as someone said, any fool can lend money, but it is the smart, shrewd banker who knows through good risk management to be able to identify good risks and bad risks. So who are the good risks amongst my customers or prospective applicants? Who are the bad risks? So with that, I'll show you some examples in financial services. And finally, beyond this tool sector, I want to just give you a quick idea of some of the other applications in HR. When you are interviewing someone, how do you know that this particular applicant, although they may have all the credentials, are likely to stay, and the reasons why this person is a likely candidate that will stay? So if you're in the search industry, or if you're the internal HR department, you're looking for tools like that to be able to augment or help you. Okay, internal audit. Okay, and this one is also one of those applications where auditors, internal auditors particularly, need to be able to understand whether the model that's been developed is valid or not. In finance, how do you know that the claims are fraudulent? How do you know that when someone submit a transport claims, that'll be fraudulent? But today in COVID, I guess, less of us traveled. But the minute you can anticipate when travel starts opening again, we can expect again the fraudulent claims, and also accounts receivable. How do you know that someone who owes you money, this is actually a good payer or a bad payer? Okay, so, and the other area, sales price forecasting. It's very important in sales, right? To be able to forecast, is the price likely to go up or likely to go down? And what's the impact on revenue? Okay, so these are some examples that I've just shared where we can apply AI and explainable AI. Okay, so applications in healthcare. Okay, I've got a few more minutes now. Healthcare will be one of the forecasted largest industry where there will be significant AI investment. Okay, so these are the forecasts in the numbers that you can see. And in the center column, it shows some of the potential areas where AI will be applied. Okay. Now, so we got plenty of data, but then how do firms actually, pharmaceuticals, hospitals, look at all these thousands and thousands of data points and images? Okay, and so with that, we are starting to see many domain applications in the space of healthcare. So the numbers show you the global AI investment, about 58 billion by next year. Right. So AI will definitely be driving and shaping healthcare, and particularly in the post-COVID new normal. Telemedicine definitely will accelerate, and we're starting to see healthcare tech companies that are heavily invested because they believe that the investors believe that that will be the next wave. Okay. Right. So I mentioned earlier about the 6 areas where AI explainability can actually help solve. And McKinsey did a global AI survey in 2019, and they mentioned that 4th on the ranking is explainability. So which means that this is actually the next area or the next frontier that will really take off significantly. Okay, I'm going to give you a simple example of explainable AI. A patient either takes an image or goes to see a doctor, and then the skin information is then transmitted, and then the model will then predict that this is likely to be cancer type A, okay, and the probability of that prediction is 85%. But then, as I said, the present AI system don't tell you the reason why. Okay? So you need an expert to come in and then look at it again. So the senior cancer specialist will look at it again and then confirm, yep, that seems to be the case, or the machine has predicted wrongly. Okay, but with explainable AI, let me show you. The original image on the left is actually the image of cancer on the skin. Okay, and the imaging now will start. You see the green spot and the red spot. It starts to actually identify those special areas, and then from there, it will then use its train data and says, aha, this is skin cancer stage 3. Okay, and then it will tell you the reason why. So you see at the bottom, it actually explains where the area is spotted, and then it even diagnoses and says that this is not only 4th-stage skin cancer, we recommend that this is what you do. And the reason why we say this is stage 4 skin cancer is because we've picked up the following thing: the skin discolorization, the change in the skin texture, necrotic tissue. Now, these are all medical terms and so on and so forth. Okay. Now, can you imagine if we combine imaging data with IoT data, where we put a patch on the wound, and the wound patch actually picks up the kind of proteins or the chemicals that are produced by the body in the wound, And together with all this data, it can even predict the skin cancer much more accurately. Okay? So I hope that you can see the power of using computer vision, AI, and analytics, explainable AI to actually solve problems in the healthcare industry. Okay? Right. I'll just skip this. This is an example of how the state-of-the-art model, the model are so accurate. So this is an example of a case study. They picked up about 600 images, okay, just from the internet, okay? And this particular machine learning model picks up, it correctly identifies 92% of orthopedic wounds, 91% of leg ulcers. Now this without actually fine-tuning the particular AI algorithm that is in the black box. So you see, it has such a high accuracy rate, even from images picked up from public domain. But obviously, wound experts around the world are actually looking to collect thousands and thousands of such wound images, and then from there to be able to see, to identify wounds. For example, can you imagine a domestic worker working in some place like the Philippines, right? Looking after the elderly, or even in Singapore. So the domestic worker should be able to take a picture of the bed sore, and then from there, transmit this picture to the AI system, and the medical expert system then will be able to then diagnose what is the issue with this sore, with this bed sore. Is it linked to diabetes, or is it has to do with the fact that the patient is not taking enough certain nutrients and so on and so forth, or they are treating the patient wrongly in terms of its bandaging and so on and so forth. So I hope that you can see that the breakthrough is that it will result in better health outcomes, lower costs, and greater outreach to healthcare industry, and potentially reduce costs significantly. Okay. Applications in finance. So first, for those in foreign exchange, okay, prediction of FX. As you know, right, in foreign exchange, whether the US currency goes up or goes down against the Sing dollar, forecasting prediction is very important. So that's one example. Another example is, I mentioned earlier, someone takes a housing loan. How then do you predict that an existing customer will default? Okay, or if it's a new applicant, how would this new applicant actually be someone that we're going to approve? Third, credit card fraud. As for those working in the credit card industry, credit card fraud is actually quite prevalent. So using XAI again, we can actually use it to detect, some of this fraud. I'm just now at this point in time giving you an overview, but later I'll show you some screenshot examples of how XAI is applied. Okay. Finally, Global Tier Bank was using it to actually classify their risks. So value at risk and so on and so forth. So with this, these are actually examples that are today applied in the financial services industry. Right. So again, global AI investment in the financial service is probably second or third after healthcare. And on the right, it shows, for example, what I've just mentioned, how the model has taken in the information about the borrower, and it looks at certain important features, and then it rejects, in this case, the loan applicant. Okay, so this is a screenshot of how the XAI predicts a loan default. Okay, so in this screen on the left-hand side, it predicts applicant number 2. So someone has made an application for a mortgage loan. Okay, so we're looking at applicant number 2. So applicant number 2 has submitted all his data, and we also have surfed the web, okay, to find out as much information as we have about the social data of this applicant. So after it's gathering all this massive data and the information supplied by the applicant, it will then say, aha, applicant number 2, okay, the likelihood of default is 85%. And the reason why we say that the default rate is about 85% is because these are the following factors we have evaluated. Okay, so again, this is one of those that we have applied live in one of the banks used by ITIS that they have kindly shared with us. So examples of this are fantastic. So can you imagine if you are a consumer loan officer, and then you meet a very upset applicant who says, hey, my loan has been rejected, explain to me why. Now, under GDPR, or especially if they are EU customer, right, you have to explain to them why, on what basis you are rejecting the customer. Okay. So finally, I want to end this session just in time. So I know there's a lot to cover, and it's very, we actually do a 14-week kind of session for courses like that in our Masters of IT in Business. So for those who are obviously interested to find out more about this area, feel free to drop me an email. And we can always answer these questions if we don't have enough time in the next few minutes on the Q&A. Now then, on the right side, just a short advertisement from the School of Information Systems. As I mentioned earlier, we are the #1 top ranked program, the MITB program, and in Asia twice for 2 years in a row, and we're ranked number 14 worldwide. So globally, this is one of the most highly ranked program, highly rated, and it obviously is a very competitive program. So we hold a regular information session. So feel free, there's a QR code there you can scan, or you go to our website, and then do feel free, to actually join us for our information session in case, you're interested. We offer 3 tracks, FinTech, AI, and Analytics. So without further ado, let me see whether there are any questions that are coming from the audience. Okay, I'm still waiting to see the question. Just give me a minute. Okay, we have 10 questions. I've got 10 minutes. I'm not sure whether I can answer all 10 questions in 10 minutes. Let me just pick and choose. Okay, first, will the slides or recording be shared? I believe the slides will be recorded, and then I think they will provide you with the link after this event. Is there any course you can recommend for us? I would say, Rikun, probably the best thing is, why don't you attend one of our information sessions, because obviously you can decide to go for very short-term, couple of days courses, or you can actually do a couple of months. So again, depends on your knowledge gap and where you are and what kind of skills you need to pick. So it's always very important when you're looking at courses, look at where the industry is heading, what are the skill sets that are needed, and what will the course offer you. So for example, if I'm going to recommend some short programming courses, learning programming in R, in Python is obviously very critical and important, but that's not sufficient for you to be the AI expert to develop AI models, okay? For that, you probably need to attend a more extended course. Now then, let me see what's the next question. Yeah, material be shared. May I know if these AIX are being used in Singapore healthcare hospitals and financial sectors? Okay, so I'm not at liberty to share with you which hospitals, because some of these projects that we are actually working live now, we have signed a non-disclosure agreement, but suffice to say, actually work is being done right now with hospitals, as well as with banks and insurance companies in this area. But obviously, these are the leading edge companies because they have an underlying AI system, and now they're supplementing with XAI to make sure that it's able to explain or help them to debug. Okay. Last year, I knew one of the company was approached by the MAS and some auditors, because they were very concerned, the MAS and the auditors were also very concerned that as new AI models are being developed, how do auditors or regulators, are they able to inspect and validate the model, right? To use human beings is possible, but it's going to take a long time, and you need to train a large pool of experts. So in short, the answer is yes. Some of it, I think, will be likely going to go live in the next 6 to 12 months, because it takes a certain amount of time to actually train the model. Okay, let me see. How do I go down? How, how do I scan? Okay, I'm trying to scroll down a few more questions. Okay, is XAI more than rule extraction? What are the types of explainable models that are used? Okay, XAI is more than rule extraction. It actually goes in and actually study the model and study also the data that's actually being used. Okay, so with that, it then can pick up any data biases by analysis of the data. Now, in terms of the model validation, it will actually look at the strengths and weaknesses of the underlying model. And from there, it will actually do some verification, particularly on the limitations of the underlying model, and then tells you whether those limitation or weakness has been picked up when the underlying algorithm comes up with those predictions. Okay. Let me see, how did we move from XAI to XAI? It's a matter of having an inter-user. No, it's not just a matter of having a user interface. We are actually putting in a couple of extra tools. And in one of the slides, actually, I showed you, there were some of the tools that we have actually built in. And so it will actually do some probing. Okay. Now, someone asked me, can you explain how this XAI works in a very simple layman's term? So I always use the example of a junior medical specialist and a senior medical specialist. Usually a junior specialist will diagnose a disease, and then you have the senior medical specialist who will then counter and then provide what we call a second opinion, and to be able to explain why he or she supports the first opinion, right? Okay, so again, we have experts in all industries, not just medicine. Okay, okay, any AI courses to recommend? Obviously, I'll recommend sign up for MITB master's program in AI, which we actually launched last year. So by all means, but by the way, there are also quite a few good AI courses elsewhere. So, but anyway, do investigate this. We have in the School of Information System, for example, we have about more than 12 to 15 faculty who are actually AI experts, and some of them have actually been given a very strong AI awards. So please come and talk to us if you need to know about which courses to attend. Now, okay, someone say, do you need to learn any other programming language like Java, Spark? Okay, Java, Spark are what I say very foundational, but I should just now mention R, Python. Okay, pick up those. Like I spoke to one of the bank the other day, and this gentleman who's the head of the department told me 3/4 of his staff knows how to program in Python. Okay. I think I got 2 more minutes. Let me just pick up. Provides telemedicine. Okay, I cannot comment about which institution company provides the best telemedicine services, but obviously we can find out, because we're actually working with some of the medical specialists, because my role is not just teaching at SMU, but I do advisory and consulting work for some of these key projects. So, and because these key projects are highly confidential, we cannot publicly share this information or even privately, but we need to get the consent of some of the companies as well as the government agencies that we are working with. Okay. Okay, in order to work for XAI projects, does one need any preliminary knowledge and experience? How about its career path and job opportunities? Okay, so first, as I said, AI is going to be a really strong area because I would say this is the 3rd or 4th wave of AI right now. And just now I mentioned about convergence. So the factors like we have bigger machines, they are able to process more data. And AI is very, very dependent on data sets. So the bigger the data sets, obviously, the more patterns it can see. And then today, we are actually moving into another area of technology called quantum computing. So these are super-sized, super-fast computers that can not only read plenty of data, but can also at the same time, speed up the processing as well. So obviously this, and the Singapore government actually has put in quite a lot of research grants also in this area. So the answer, yes, the future is bright. If not, no government or investors will put money in this area, okay? So obviously a basic knowledge of AI is important. And then from there, you then progress on to the next step on then to be an XAI model developer. So I think that's about all the time I have at this point in time. And thank you so much for all your questions. And I apologize for going at such a fast pace. And I assure you, I'm not a machine, I'm a human being. And so please, if you need to follow up, by all means, come and drop by at SMU. We're quite happy to respond to you either by email or have a cup of coffee if you need to chat with us. We're all very friendly people at SMU. Okay, with that, thank you very much for spending this time with us. Thank you.